Find the slope of the curve y equals 4 over x at the point 2, 2. So in other words, we're looking for the slope of the line that is tangent to this curve at the point 2, 2. And we would do that by finding the slope of a line that is secant to the curve and then decreasing the distance between the secant points. I'll draw a graph that exhibits what we're trying to do here, since there isn't room on our graph over to the left. So let's say that we have a point here and a point here. We could draw a line that would be secant to the curve through those 2 points. Now, if we were to imagine bringing the second point closer to the first and then drawing another secant line, we could keep doing this until finally the distance between them is 0. And rather than having 2 points, we would have 1 point and a tangent line. So that's what we're going to try to do. So we have the function y equals 4 over x, and we're going to start at the point 2, 2, and then look at a point that is very near to 2, 2. In fact, one that is h units away. So we have the function y equals 4 over x, we have the point 2, 2, and if we look at a x value that is h units away from 2, we would call it 2 plus h. And then the function value would be 4 over 2 plus h. If the x coordinate is 2 plus h and the function is y equals 4 over x, then the y coordinate would be 4 over 2 plus h. Now let's find the slope of the line that is secant to the curve at these 2 points. So we would be finding delta y over delta x. So that would be the difference in the y values, 4 over 2 plus h and 2. And then the difference in the x values, 2 plus h and 2. Now, we have a problem here. If we were to do a little bit of simplifying here, we would have 4 over 2 plus h minus 2. And in the denominator, the 2's would cancel and we'd have just h. Now, what we talked about doing was diminishing the distance between these 2 points until that distance was 0. And if that distance is 0, then that means that that value h is 0. And we can't substitute 0 for h in this form because it would be undefined. So what we have to do then is manipulate this complex fraction and see if we can write it in a form where we would not have a 0 in the denominator. One thing that we might do is think about, well, what do we do whenever we have a complex fraction? We multiply the top and bottom by the lowest common denominator of all fractions inside the complex fraction. And we notice that the only fraction inside this complex fraction is this fraction 4 over 2 plus h. Its denominator is 2 plus h, so we'll multiply that on the top and bottom. Now what will happen, we will distribute over these 2 terms in the top, and in the first term, the 2 plus h would cancel, so we would have 4 minus 2 times 2 plus h when we distribute. And then in the denominator, we would have h times 2 plus h, which would give us 4 minus 2h over h times 2 plus h. Now, in the numerator, we can eliminate the 4's, so we would have minus 2h over h times 2 plus h. Now the h's can cancel, and we wind up with minus 2 over 2 plus h. And now we can substitute 0 for h, since we would no longer have a 0 in the denominator once we've done that. Remember, what we're doing is we're taking this point, which in this case is 2, and then we're adding this distance h, which puts us at 2 plus h. And then we're making that distance get smaller and smaller until it goes to 0, and we are left with only the 1 point. And we would do that by letting h be equal to 0. So now substituting, we have minus 2 over 2 plus 0, or minus 2 over 2, or negative 1. So in other words, then, the slope of the curve, or the slope of the line tangent to the curve, the same thing, at that point would be m equal to negative 1.